Welcome back again. So here we are. I'm going to share these slides with you. As well, we have many video about these sections. Now, in Cal 2, we have 8.8 and improper integral. Improper, we have two types of improper. One of them is with infinity and minus infinity, and the other is with vertical asymptotes. So here we are. We have two types. The first type is like that. You can see from here. Type 1. We have infinite in up or minus infinite in low down. I mean upper boundary limit and lower boundary limit. And as well, we have both cases. Maybe we have both cases. So how we solve that one? You can see from the example to convert this integral to a normal integral. We are going to change infinite to b. Then later we need what? The value of b. How? By letting the limit. So here limit is include and limit all ideas about the limit. Here we recalled here again. So you can see the first example is solved by the limit. So all idea in limit is required here. You need to review all things that we need here, especially for first part of 8.8, because as I told you, it's two parts. We have limit x approach to infinite or minus infinite. And here we have vertical asymptote, second part. So you can see in the second part here, second type, sorry. Here's another type. Here we have asymptote. We have a number, but the number will make asymptote, make a vertical asymptote. Okay? Encourage you say Darkanari Stuni. So here we are, you can see from here, as is that example. Between 0 and 1. If I substitute 1 here, I will get what? I'll get 1 over 0, which make a asymptote. That's why at 1, we have asymptote. That's why we need to change that integral to limit. Here we are. 1 changed to b, and b is going to 1. So we use the limit idea. So both cases depends on the limit. So we are going to review those ideas that we need. In chapter 3, in your lecture, in Cal 1, we have many idea of limits. One of them, it was limit involving to infinite. So you can see limits involving infinite means that those limits that are going or is going to where to infinite or minus infinite. Understood? So here we are, the first example. This is in the 2.6 in Thomas Calculus 14th edition. So you can review it, or you can use the video that I am going to provide you in Cal 1, or here we are going to review it as a first time. So here we are. We have what? We have limit of 1 over x. Let me start with the easiest one. Limit of x approach to infinite to 1 over x. So is equal to what? I'm going to substitute in my mind. I said it be infinite. So it will be what? It will be 1 over infinite. 1 over infinite means that 1 over 1, 1 over 2, 1 over 3. You can see here we are from 1 and you are from 0. So at the beginning, we are get 1 over 3, 1 over 2, 1 over 4, 1 over 99, 1 over more 9, and we are close to here. Our diagram is going to where? It's going to decrease to 0. That's why we say is equal to 0. Again, if you have a limit of x approach to minus infinite to 1 over x, again the same. We have minus 1, minus half, minus 1 over 999. So again, we are close to what? To 0. As well, if I change that example to x squared, nothing changed. X approach to infinite or anywhere. So nothing changed. And careful, we are going to use this idea again in chapter 10. All this. So kindly pay attention for limit approach to infinite. So again is equal to what? Like 1 over x, 1 over x. Am I right? So like 1 infinite over 1 infinite. Like a 0 multiply 0. So by the result, we say is equal to what? Is equal to 0. Do you have any question with that, dears? With that example? Good. So here we are. You can see in chapter 2, if I have any numbers, that is numbers, any numbers. In my mind is number, a number. For example, 2. I don't care. But because I have 1 over x squared, in my mind, I say is what? Equal to 0. So number multiply 0, the result will be what? 0. So how about if I have something like that? 5 plus 1 over x. I know 1 over x is equal to 0, as well as a rule if I have any number constant, and that one is going to infinite, minus infinite, any number, the constant still remains constant. So is equal to c. Example to clarify for you. For example, you have 5, we say is equal to 5. That's why in chapter 2, in Cal 1, if you have such limit like that, I say that part equal to 5, that part is equal to 0. So that's why I got 5. Again, we say that one is equal to 0. Do you have any question about these two examples? No. Now in example number 3, we have 3 cases. Here maybe A, let me check. Maybe A, yes, B, I'm waiting for C. No, we have no C. So I'm going to change this example to 3 parts. For example, I'll give you the idea and you apply the same idea here. For example, if you have x approach to infinity, you have polynomial over polynomial. P of x, Q of x. Let P be with n, Q be with m. So we have 3 cases. As we said, maybe n greater than m, maybe n equal, maybe n less than m, right? For example, we have x to power 3, x to power 2 minus 5 over x to power 2 minus 2. If I try to find the limit here, x approach to infinity, I say because numerator is greater, I will get infinite directly. How? We say both side, or sorry, both part of the example, I mean by numerator and denominator, we are going to divide by highest degree of denominators. So x to power 3 divide by x2, x squared by x squared, 5 by x squared, x squared by x squared, 2 by x squared. You got why? Because higher degree is what? In denominator is square. So in up, I will get what? In up, that one, it remains just x, right? It remains just x. How about that one? 1. And that one, it remains self. How about that one? 1, right? Now, take a limit. Take a limit. Limit for x, limit infinite to x equal to infinite. Am I right? Limit infinite to 1 equal to 1. Limit infinite to 5 over x squared, we say that is equal to 0. Limit for 1, 1, again 0. So it remains, sorry, it will be infinite over plus 1 over 1, right? And it's equal to infinite plus 1. Infinite, a lot. With 1, no sense, right? Just infinite. That's why we say if in the first case, if numerator is greater, we will get infinite. Where x approaches to infinity, and what we have, polynomial over polynomial, qmx. Okay. Now, how about if they are equal? How about if they are equal? So I'm going to the second example, equal. What do you mean by equal? Both numerator and denominator, yeah, the same. For example, x squared minus 5x plus 2 over x minus x squared plus 5. So in that case, let that one be minus. In that case, we say is equal to the coefficients. What do you mean? coefficient of here, let be that one be 2 and that one be 3 to be more clear. So the coefficient here is 2 of higher degree, and the coefficient of here is -3 of the higher degree, and both degree are equal to 2. So I see is equal to 2 over -3. So the result of x approach to infinity is equal to 2 over -3. So in that case, if they are equal, I see equal to what? I see equal to coefficients. Understood? Now for the third case, I see is equal to 0. How? For example, if I have limit of x approach to infinity, x to power 3, 5x to x squared plus 2. So in that case, again, if you divide by 3, divide by 3, divide by 3, I mean x cubed, that one will be 0. That one again will be 0. That one will be 1. That one will be 1 over x. That one will be 0 or 0. So I got what? I got 0, 0, 1, 0, 0 is equal to 0 over 1 and is equal to 0. So directly I can see is equal to 0. That's why. Understood? Clear? So tell me about that example. Is equal to what without doing any calculation? Doing 5 over 3. Why? Yeah, so the degree are equal. So the second case of the polynomial, right? So how about the second example? How about the second example here? 0, why? That one is greater. Understood? Now, this is the review of the limits. So here we are. Forget about these examples that are talking about asymptote. And the important thing is what we know. 1 over x is equal to 0. We don't care about the details. Now for here, I don't care about the details. I say I will get 5 over 3 or 5 over 3. Understood? In Cal 1, I don't care about the information about horizontal, vertical. No, I'm caring about limits, just only limit. That's why I say quick. So how about that example? Look, here we are. How about that one? Is equal to what? Because limit approach to infinite from positive part. Okay, and that one will be positive. So I will get such fraction like that, quotient like that, and I know that one 1 over 1. How about the second? If it's approach to minus infinity, so that one means that is minus. So and I know is equal to 1 over minus 1. So the limit will be -1. You got the idea? I know I'm fast, but you know you don't need to. Yeah, I see. Thank you. You don't need to be slow here because we saw many things here. Again, we have sine of 1 over x. Okay, so sine 1 over x and x over sine over x. I don't know, maybe we need this idea again, so I'm going to review for you. So if we have sine over 1 over x and x approach to infinity, maybe we cannot deal with it. Why? Because we don't know sine is going to infinity is like that, right? Sine is like that. So we don't know when we are going to infinite, it's like that, it's like that, we don't know. Maybe it's like that, right? So to clarify that one, I'm going to use the substitution. I say let, in your lecture not write t. Maybe you can say u, maybe you can say theta, up to you. So I'm following the same. So let t be 1 over x. Why? Because I know if I say x approach to infinite, one sine of 1 of x, I can change it to something sine of t. That one is easier, right? So 1 over x is what? Is t. Now, so we should change x to something to t here, right? Am I right? So if x approach to infinity, 1 over x approach to where? 0. So that's why I say t is approach to 0. So t is approach to 0 from right side. Now, my limit from x approach to infinite, sine of 1 over x, change it to t approach to 0, sine of t. Am I right? I change that one to t, and I change that one to t. Of course, that one also changed to something else. You got it? Hello? Good. Now, sine of 0 equal to sine of 0, 0. So that's why the result will be 0. So I say the limit approach to infinite for sine of 1 over x is equal to 0. Here we are. Here's the result. Here's all things that you need. Now, the second example is very important, x sine 1 over x. So how we solve that one? X sine 1 over x, where x approach to where? I don't know. Let me check in Cal 1 to both positive or negative infinite. So I'm going to positive infinite, okay? So let me solve that one. Again, I'm going to change x to be what? 1 over y, because that one will easier for me in my mind. So I will get sine of t at least. Am I right? So how about this x is equal to what? X will be what? 1 over t. Well, understood. If x if t equal to 1 over x, then x equal to what? So we say t over 1 equal to 1 over t, sorry, 1 over x, multiply, you will get xt equal to 1, so x is equal to 1 over t. Now, if x approach to infinite, t is going to where? You know from the previous one. X approach to infinite. So t is going to where? 0, right? So we say that limit x approach to infinite, x sine 1 over x is going to be limit t approach to 0, sine of what? T 1 over t. That x will be what? 1 over t. So here's 1 over t. Right? And then later this x, that x changed to 1 over t. So I'm going to organize t0 sine t equal to t. And that one is the formula. You saw that one is equal to 1. Thank you. So here we are. This example will be 1. And of course, the same is true for negative infinity. These quickly, forget about it. This example, you know, this is the review of those things that we need. Now, if I have sine of x, now that time I have sine of x over x. So how we solve that one? When you have sine over something, it's easy. Yes? Theta? No, easier one. Something else. Sandwich theorem, you remember. So, sandwich theorem. Why? Because we have sine, we know. Sine is between what and what? Hello? Huh? Between 1 and minus 1. So I have 1 over x, 1 over x, 1 over x, right? Limit to that side to infinite. Limit of that side to infinite. Limit of that side to infinite. I know 1 over x is equal to 1 over minus 0. So of course that one will be what? 0. You got it? So how we solve that one? If approach to infinite. Do not worry about that one. I'm going to repeat this one for you. Equal to 1. By sandwich. Okay. Equal to what? So make a difference between these two. That one's formula. You can use L'Hopital again or by other formula, and that one is by Sandwich theorem. You got it? So, of course, 0 plus 2 equal to 2. Now, another type of question. Look at here. I'll get what? يلا جماعة. X squared. If your mind is not here, if you are not with me, actually you feel there's heavy things in your shoulder and mind. So kindly be with me. So we have what? Let me check. X minus x squared plus 16. Yalla, I will get what? The result. Just give me the result. 0, 1, 2, 5. 0. Why? Infinite minus infinite is 0. Any other idea? Why? Hello? Infinite minus infinite is indeterminate form. Means that we don't know is equal to what. Why? Infinite plus infinite is equal to infinite. Infinite minus infinite, sorry, minus infinite. But here we cannot decide anything. Why? Because maybe that infinite is greater than that one. So I'll get infinite. Or maybe that one is greater than, so I'll get minus infinite. So because I have two cases, I don't know. So infinite minus infinite later in chapter 8, don't worry, in chapter 7, 5, in Cal 1, again we have some formula of L'Hopital's indeterminate form. You can see indeterminate form. So here one of them is what? One of the shape. Later I will go back to here. Is what? You can see infinite minus infinite. Just give me a second. Look. That one. So in the indeterminate form, we have many types. One of them is like that. So that's why we are going to multiply by conjugate. That you see. Okay? So because I will get infinite minus infinite, that's why I say limit of x approach to infinite, okay, x minus x squared plus 16 multiplied by conjugate. X plus x minus 16, x plus x minus 16 square. Do you have any problem? And you know, when you multiply two things with a different sign, we say first square minus second square. Am I right? It will be on what? X plus x squared minus 16. When we multiply two brackets and let me do it nicely. When we multiply two parentheses, two brackets, I'll get difference between two squares. First square minus second square, usually. So that's why we got what? That's why we got first square minus second square. And the second square will be what? Will be removing the square root. Now, limit of x approach to infinite is equal to what? You can see minus. I will get minus 16 over x plus x squared minus 16. Limit x approach to infinite. And I know denominator is greater here, so I'll get what? Third case, I don't know. Second case, which one? Polynomial over polynomial. Here's greater. Otherwise, you can put this infinite here. I'll get infinite plus infinite minus 16. So is equal to infinite. Square root of infinite. So infinite plus infinite, again infinite. right? And up we have minus 16. Then I'll get what? Number over infinite we see is equal to 0. So here we are. After multiplying by conjugate, we will get what? We will get 0. Yes?
You should change the signs over the square root or
Inside?
inside the square root.
No, we don't change anything. I changed it after multiplication. Here's, I changed it. So it's a mistake. Sorry. It's by mistake. So I'll get what? That one's positive, right? Yes, positive. Not all, all it's true. It was a mistake, sorry. Thank you. You shouldn't change that. One sign will change. Okay. Just here, just here. No more. Here we are. So tell me about the limit of here. Infinite. Result is what? Why? Yeah. Numerator is greater. Thank you. So let me see which one we need more. Okay. So that's all about limit at infinite. Do you have any question involving infinite? No. And I'm going to give you such clue in chapter 7.5. Of course, we need this section actually. Yes, here we are. We have indeterminate form. We have three types of indeterminate form. One of them is 0 over 0 or infinite over infinite. And the second, 0 multiply infinite, infinite multiply 0, okay? Infinite minus infinite. And the third one are powers. Powers like 1 over infinite, 0, 0, infinite, infinite, infinite 0, 0, infinite. I don't know, maybe I forget something else, but mostly they are like that, mostly. Understood? Look at the shapes. These all are indeterminate. Indeterminate that we don't know is equal to what? We should change. We should multiply. We should use algebraic. Maybe we multiply by conjugate, as you saw before. Maybe we use the L'Hospitals. What's the L'Hospital? Derivative numerator separately over derivative denominator separately, not together. So all these ideas, we need them. And we are going to use, if I have this shape, I should change it to that one. If I have this shapes, this formulas, we should change it to that one or that one. Whatever they are, easy. Now I'm going to the example here. You can see, this is a review for you actually. You can see from here, if I have such a number like that, even for 0, careful. Here, L'Hospital is dealing with all types of the indeterminate, not just limit approach to 0, to infinite. Okay, Jamaat? Here we are dealing with all of these. Chapter is Hauta. We are not going to talk about just infinite. We talk about indeterminate form. So maybe infinite, maybe 0, maybe number, I don't know. Maybe pi, we don't know. So the important thing is we get this one, or we get that shape, or that shape, and depends. So here we are. If I put 0, look at here. If I put 0, I'll get 0. And I'll get 0, and I'll get 0. So 0 minus 0 will be what? Will be 0. So I get this formula. Am I right? So that's why I say because I got indeterminate form, I'm going to derivative here, make a derivative. So 3x will be 3. Derivative of sine, cosine. Derivative of x, 1. So we got that result. And I know Then after each step, you need to review your limit. So look at here, if I put 0 here, I will get 3 minus cosine of 0, 1. So I say 3 minus 1 over 1. So I'll get 2. Easy. If you understand, the idea is easy. Otherwise, yes, it's actually hard. You talk about many things today. But if you understand what I'm going to say, you know. How about that one? If I put 0 in denominator, I'll get 0. How about if I put 0 here? I'll get 0. 1 minus 1 is equal to 0. So I got 0 over 0. Again, you can multiply by conjugate, or you can multiply by what? Or you can derivative them. So I'm going to use the derivative. So I say the derivative of denominator equal to 1. Am I right? Hello? How a derivative of here? 1 over 2 itself, right? So 1 over 2 itself. And if I put 0 here, I see is no problem. If I put 0 here, I see is not problem. So I'll get 1 over 2. Maybe you have many examples here. Again, if I put 0, 0, 0, I'll get 1 minus 1 minus 2. And we are going to use the derivative and we find the value. Yes, I like that. I do like that. Both of them, you should substitute both of them, numerator and denominator. So no, sometimes for that, how about that one? If x approaches to 0. So you don't say it's not. Yeah, why not? You say it's 1 over infinite, 0 is equal to infinite. Why not? So that is equal to infinite. No. For limit, no. For function, yes. For vertical asymptote, yes. But for limit, no, we substitute. We say 1 over 0 is like 1 over 999. So 1 over 99 is equal to 1 more, and so we get infinite. That's why I say no. You got it? So here again, if I substitute 0 in denominator, listen, I'll get what? 0. How about here? 0 minus 0. So derivative of here, and this example is very important. When you saw x to power 3, do not think about 3 times we are going to use L'Hopital. We don't know. We should substitute each time. Look at this example. So I say x to power 3, we derivative them, and I'll get what? Derivative of sine, cosine, derivative of here is equal to 1, here is equal to 3x. Now I'm going to substitute again, again, the same. 0, I'll get 1. I'll get 1 minus cosine of 0 over 0. So again, I got 0 over. That's why, again, I'm going to use what? Derivative. So derivative of here, 0. Derivative of cosine minus sine minus minus will be positive, 6x. Substitute. We don't say 0 over 0. You can? What? We say is equal to what? You can solve that one by 1 over x, x0, sine x over x. And you know that shape is equal to 1. Am I right? Or you can again use what? L'Hopital. So derivative of sine, derivative of 6x, 6. So we got that one. And I know 1 over x. Now, look at the other example. So tell me, how many times we need to take a derivative? Yalla. 2 times. Why? So let me do it. I told you do not say that. We say do not say that. You should each time you substitute. Yalla, let me do. Yalla. Derivative first we substitute, right? So I'll get 1 minus 1 here over 0. plus 0, right? So we go 0 over 0. Derivative of 1, derivative of cosine, sine, derivative of here is equal to what? 1 plus 2x, right? Okay. So substitute. You will get what? In the up, I'll get 0. In down, so it's equal to what? 0. So you don't need 2 times. I told you, when you saw 3x to power 3, do not say we need 3 times. Maybe, maybe not. So in that example, we used 3 times x. But in your mind, you shouldn't say because x cubed, we need 3 times. Because x is squared, we need 2 times. No, depends. So each, that's an example, is counter example for your idea. So depends on the number that we get. After each L'orbital, we need substitute. That's the rule. And you get 0 instead of 1 over 2. 1 over 2 is mistake. The actual or the correct answer is 0. You got the idea, dears? Yes. Yeah. Yes, the same. Here we are, it's easy. That one for you. And this is another part. Okay. So I'm stopping here because I know you are just look like a child and not understand anything. Next lecture, we are going to finish from here.